It is time for the last section of Chapter 6, which is about solving radical equations and inequalities. So part of this will be review because we've done a little bit with square root equations before. So this is going to kind of be somewhat review and then extending it beyond just square roots to cube roots and fourth roots and fifth roots and all of that good stuff. So we have solved polynomial equations before. So today we're practicing solving equations and inequalities that contain different kinds of radicals. So the vocabulary to look for in this section is radical equation, extraneous solution, and radical inequality. All right, so the steps to solving radical equations. Step 1, this is important, is you must isolate the radical on one side of the equation. Even if there's two radicals, you have to get at least one radical isolated on one side. Then we're going to take a power of each side. So we're going to raise each side of an equation to the power equal to the index of the radical. So that means if I have the square root of x equals 10, I'm going to square both sides. If I have the cube root of x equals 10, I would have to cube both sides. Whatever I do as far as my exponent has to undo or cancel out the radical. And then we solve whatever is left. All right, so we're going to solve the square root of y minus 2 minus 1 equals 5. Okay, so notice this negative 1 is not underneath the radical. So I'm going to add 1 to both sides so that I isolate the radical, meaning I have to get the radical by itself on one side. So I have the square root of the quantity y minus 2 equals 6. Then I'm going to square both sides because squaring will undo a square root. And I get y minus 2 equals 36. Then I add 2 to both sides. And I get y equals 38. Now we always have to check. Why? Because sometimes, because we're getting rid of radicals, we might get something called an extraneous solution. So sometimes, even though I got x equals something or y equals something, when I check it, it does not work. So you always have to check radical equations. So here's my original equation. I'm going to replace y with 38 because that's the solution I got. And then we're going to simplify this. This gives me the square root of 36 minus 1, wondering if that equals 5. The square root of 36 is 6. 6 minus 1 is 5, so it does work. So 38 is my solution, but you always have to check. All right, let's try this one. Notice this one's a little different because I have a radical on both sides of the equation. So here's my original equation. And normally we would say, okay, we're going to isolate the radical, but in this case, I have two radicals. So I just want to make sure that at least on one side of my equation, I have a radical by itself, which I do here on the left side. On this side, there's nothing outside of the square root. So I'm going to go ahead and square both sides. I'm going to square the square root of x minus 12, and I'm going to square the binomial 2 minus the square root of x. So notice over here, the square root of x minus 12 squared, the squared and the square root just cancel out, because in this case, the square root is the outside operation, and the negative or the subtraction is underneath. On this side, I have two separate terms, right? I have 2 minus the square root of x. So be very careful. This means 2 minus the square root of x times 2 minus the square root of x. So here I have to FOIL. 4 minus 2 square root of x minus 2 square root of x, that's where the negative 4 square root of x comes from, plus x. And now I need to isolate my radical again. So I'm going to subtract x from both sides, right? So those x's will cancel. And then I subtract 4 from both sides. So that gives me negative 16 equals negative 4 times the square root of x. Divide both sides by negative 4. So I get 4 equals the square root of x, and then I have to square both sides. So 16 equals x. And again, I'm not finished until I check my radical equation. There's my original equation. I'm going to plug the 16 in everywhere I see an x. And notice here I get the square root of 4, and I'm wondering, is that equal to 2 minus the square root of 16? So on the left-hand side, the square root of 4 is 2, but on the right-hand side, I end up with negative 2, and those are not equal to each other. So even though I got x equals 16, it does not work in the original equation, so it is an extraneous solution. There is no real solution here. So this solution, this 16 equals x, is called an extraneous solution. We were able to get to it because by squaring everything, we got rid of the square roots and we just solved a polynomial equation, but it is extraneous because it does not check in the original radical equation. Okay, try this one. Okay, your answer here is C, 67. And there's the work to show you how to get that answer. Again, make sure that you check. And try this one. The answer here is D. In this case, there's no real solution. And here's the work to show you how you got to no real solution. Your extraneous solution is x equals 4. It's extraneous because when you check it, you end up with 3 equals -3, which is not true. All right, let's talk about cube root equations. So here I have the quantity 3y plus 1 to the 1/3. Remember, 1/3 is the same as saying that this is the cube root of 3y plus 1. So we're going to start by isolating the radical. So I'm going to subtract 5 from both sides. That's how we got to this next step. And then, because this is a cube root, I'm going to cube each side. So I'm going to take -5 cubed and 3y plus 1 to the 1/3 cubed. That gives me 3y plus 1, because 1/3 times 3 with exponents, that's 1, so I undid the cube root. Then -5 cubed is -125. And then I just solve like normal, subtract 1 and divide by 3. And then, of course, I check. So there's my original equation. I plug in -42 for y. -125 to the 1/3 plus 5. That's the cube root of -125, which is, of course, -5. -5 plus 5 is 0. So that works out, meaning that my solution is -42. Okay, so you guys try a cube root equation. Try this one. Your answer here is 13. And here's the work for getting to 13. And then also, again, you have to check. All right, let's look at this one. We have a more general radical equation. This time I'm talking about a 6th root equation. So we're going to pick our solution from one of these. So just like with all of the other radical equations, I have to isolate the radical. So we're going to add 4 to each side, just like normal. Then divide both sides by 7 so that I get the root by itself. Remember, I'm trying to isolate the radical. And then, because this is a 6th root, I'm going to raise each side to the 6th power, because that will undo the 6th root. So I end up with 5m plus 4 equals 64. Then I'm going to subtract 4 from each side and divide by 5. So I end up with m equals 12, which is C. Again, this is one that you would have to show the check for. I'm not going to show you the check right now, but you would need to plug 12 into the original equation and test out and make sure that it works. All right, here's one for you to try. In this case, you should have gotten B. All right, there's the work for how you got to the answer of 242. And then here's the check proving that it works. All right, for the last part of this video, we are going to talk about solving radical inequalities. Step 1 is, first of all, this is an extra step if the index of the root is even. So if I have a square root or a 4th root or a 6th root or an 8th root, I have to identify the values of the variable for which the radicand is non-negative. Basically, I have to find the domain, because here we're only going to be dealing with real number solutions. So I have to make sure that any x number that I plug in, any value I plug in, will give me something non-negative, meaning either a 0 or a positive number under the even root. Then I'm going to solve algebraically, and then I have to test values to check my solution. All right, so let's take a look at this inequality here. I have the square root of the quantity 3x minus 6 plus 4 is less than or equal to 7. So since this is an even index, it's a square root, I have to say, okay, whatever is under the square root, which in this case is 3x minus 6, that has to be greater than or equal to 0. Whatever is under the square root cannot be less than 0, because we're going to be dealing with real number solutions. So that ends up giving me that x has to be greater than or equal to 2, which they probably show you down here. So that's the first step. This is going to be part of my answer. So I can't have any numbers smaller than 2. I have to be greater than or equal to 2. So now we're just going to solve this algebraically, right? We're going to solve the actual inequality. So I'm going to subtract 4 from both sides to isolate the radical. That's what we did right here. Then I'm going to square both sides to get rid of the square root. So basically here we squared and we squared. So 3x minus 6 is less than or equal to 9. Add 6 to both sides. And I end up with x is less than or equal to 5. So what that means is that x has to be less than or equal to 5, and we also saw that x has to be greater than or equal to 2. So the result of this is a compound inequality where x has to be between 2 and 5, including 2 and 5. Now, if this had been a cube root or a fifth root or a seventh root, an odd index, I wouldn't have had to worry about this extra part, okay? Because it doesn't matter if I have negative numbers under odd roots. But when the index is even, I have to make sure that I restrict my domain so that I only have positive or 0 under the square root. So now what we're going to do is we're going to check that this range of values is actually the correct solution. So if we were to say that this was our function, right, we're going to test one value that's less than 2, one that's between 2 and 5, and one that's greater than 5, because remember, this is what we said our solution was. So we're going to test values basically, if we were to think of this as a number line, I'm going to make sure that it actually works in here and not out here. So look what they did here. They picked 1 because 1 is less than 2. When I plug it in, I get the square root of -3. That's not a real number, so that doesn't work for our inequality. When I plug in 4, remember our original inequality says, let me write it out for you here, that the square root of 3x minus 6 plus 4 is less than or equal to 7. Here I got the square root of -3. I can't compare that to 7. When I plug in 4, which is inside the interval that we think is the answer, I end up with 6.45, which is less than or equal to 7, so that works. If I plug in a number larger than 5, notice I get 7.46 in this case because they plugged in x equals 6. I get 7.46, which is not less than or equal to 7. It's bigger than 7. So that does not satisfy the inequality. So this proves that the range of my solutions is between 2 and 5, including 2 and 5. All right, you guys try this one last problem. All right, in this case, your answer should be C. All right, here's the work. The first part, since this is an even index root, is restricting our domain. So I know x has to be greater than or equal to -5/2 so that I don't get a negative number under a square root. Then the second part is just solving it algebraically, so I get x is less than or equal to 58. So that means that x has to be less than or equal to 58, but greater than or equal to -5/2. Then if I were to check a number in each section, you would find out that below -5/2 would not work. Between -5/2 and 58 is true, and above 58 would also not work. So make sure you try each of those. And I will see you in class to practice. That is the end of chapter 6.